Hi everyone, we're Group 17. Our project focuses on automatic speech recognitions for three African languages, Kinyarwanda, Swahili, and Luganda. These languages are spoken by over 200 million people across East Africa and Central Africa. Despite this huge user base, they remain underrepresented in modern speech technology tools. The main challenge is that, unlike English, these languages don't have strong ASR systems. This creates a real barriers, limiting access to healthcare, education, banking, and government services that increasingly rely on voice technology. Our goal is simple: take audio as input and produce accurate text. To do that, we evaluated three systems. One, a conformal CTC baseline model. Two, two language model enhanced versions to see how much we could improve the transcription accuracy.
We use three datasets for our work: a curated Swahili and Luganda dataset from Common Voice, Swahili text data available on Kaggle, and AfroVox test dataset for all evaluations. The baseline model is a conformal CTC model with 121 million parameters. It combines the strengths of a convolutional neural network and a transformer to capture both local audio patterns and long-range context. To improve the baseline, we considered two approaches: an internal language model. This was done by adding an auxiliary training head with weighted loss to regularize the encoder to learn both acoustic and language features. The weighted loss is simply a combination of CTC loss and cross-entropy loss. For the second approach, we trained a 5-gram language model and used it during inference to rescore the candidate prediction by the CTC decoder. Finally, we evaluate the performance of the model of these extensions using word error rate and character error rate.
Here's what we found. In our first experiment, where we used the conformal CTC with the internal language model, we saw improvement across all three languages. The strongest gains were in Swahili, where the error rate dropped by about 42%. In our second experiment, using the external KNLM, the benefits were more limited. It only improved performance for Swahili, mainly because it had the most text data to support a well-trained language model. Overall, both models outperformed the baseline, and they worked best even when more data was available. This suggests that our proposed approach has the potential to reduce errors even further when trained on larger data sets.
Okay, the challenge we faced were three challenges. The first one was data scarcity for Kinyarwanda in Luganda, resulting in low performance in the language models. Additionally, lack of compute. Training a 121 million parameter conformer plus LM heads is expensive. Limited GPU memory meant fewer experiments. Lastly, we faced some environmental conflicts related to loading the datasets, some of the datasets, and those dependency issues were fixed. In conclusion, uh, language-specific models with enough data work well with better than other models. And so the goal for ultra-low resource language should be synthetic data plus diversifying domain. And other findings include multitask learning using both linguistic and acoustic supervision need more experimental works, but they work from what we have seen with more data. So the next step should be performing more evaluations on the language model, on the KNLM model, and synthetic data generation with other models like Afro text-to-speech models, and diversifying the data to multiple domains for higher performance.